Hello students, let us solve the problem number 5.164 of IRDOV, where two identical imperfect polarizers are placed in a way of a natural beam of light. When polarizers planes are parallel, the system transmits 10 times more light than in the case of crossed planes. Crossed means perpendicular to each other. Find the degree of polarization of light produced. Let us work out in first case, that is where each polarizer separately. So we know that when a light is traveling along z direction, the electric field vector is in xy plane. So always the electric field vector is perpendicular to the direction of propagation. Then Ex is equal to E naught cos theta, Ey is equal to E naught sin theta. Then intensity is proportional to square of the electric field. So Ix is I naught cos square theta, Iy is I naught sin square theta. So when plane polarized light incident on a perfect polarizer, just underline this word, perfect polarizer of the where the transmission axis is y-axis, when the plane of polarization and transmission axis are parallel, that is we know that the transmitted light I is equal to I naught cos square theta, which is Malus law. Here what is theta? The angle between transmission axis of the polarizer and the plane of polarization, that is vibration or incident light. When theta is 0, that is parallel, we'll get maximum light. Theta is 90, 0. That is in case of perfect polarizer. Let us try to understand what do you mean by imperfect polarizer. Imperfect polarizer. So it is the one, it can absorb the component which should be transmit. It can transmit the component we should absorb. Okay. So underline this word. It can absorb the component which is supposed to transmit. It can transmit the component which is supposed to absorb. So then the intensity of light after passing through imperfect polarizer is I is equal to I A into I naught cos square theta plus B I naught cos sin square theta. For a perfect polarizer, A is equal to 1, B is equal to 0. So here what is A? The fraction related to parallel component. Here afterwards I am using the word parallel component. B is the fraction related to perpendicular component. Perpendicular component. So if polarizers are perfect, then I naught is the intensity of light here, and the transmitted light I1 is given by Malus law. Again, the intensity of light that is transmitted by second one is I2 is equal to I1 cos square theta. Then we can write I2 is equal to I naught cos square theta into cos square theta. So if theta is 0, I1 is equal to I2, theta is equal to 90, the transmitted light is 0, intense light. Next. Now, in case of imperfect polarizer, so it can transmit parallel component as well as perpendicular component. So parallel component, let us say AI naught. Perpendicular component, BI naught. Okay. If it is a perfect, B value is 0. If it is imperfect, B value is not B. Small fraction, it can transmit also. Then after second polarizer, then AI naught into A, that is parallel component, perpendicular component BI naught into B. Okay. So the total intensity of after second polarizer is A naught square I naught plus B square I naught. Then total intensity is A square plus B square I naught. Now look at, if two imperfect polarizers are crossed means the angle between them is 90. The angle between them is 90, perpendicular to each other. So in the first case, when I naught is the light of incident light, intensity light, parallel component A I naught, perpendicular component is Bi naught. So now, because the second axis is perpendicular to first axis, first one is y, the second one is x, then this ai naught becomes b into ai naught after passing through second polarizer. This bi naught becomes a into bi naught after passing through second polarizer. So parallel component and perpendicular component reversed. Okay. Then the intensity of light after passing through second polarizer is b into a naught plus a into bi naught. So the intensity, total intensity is 2ab I naught. So this is the intensity after passing through second polarizer, that is imperfect polarizer. Both are imperfect polarizers. So in case of imperfect polarizers, if they are parallel, the maximum intensity, that is a square plus b square into a naught. If they are crossed or perpendicular, then the minimum intensity 2ab into E naught, I naught. 2ab into I naught. So now the degree of polarization P is defined as a minus b by a plus b. A is the fraction which is parallel component, b is the fraction which is perpendicular component. Definition. Okay. Or this a minus b by a plus b can also be expressed by using simple algebra. P is equal to root of 1 minus 2ab by a square minus b square divided by 1 plus 2ab by a square plus b square. So, but it is given that I maxima is 10 times I minima, is given. So a square plus b square I naught is equal to 10 times 2ab I naught. So now we got 2ab by a square plus b square is 1 by 10, and substitute in the polarization formula, degree of polarization formula, you will get 0.9.